Okay, ladies and gentlemen, let's move on to section 4.2. Now, section 4.2 has the idea of adding and subtracting polynomials. Now, before we get started, we've got to learn the lingo. We've got to know the language so when we read the directions, we know exactly what it's telling us to do. One of my favorite sayings coming up is what to do when. So, let's look here at some different terms that we need to know. When we look at the word monomial, monomial is one term. That prefix mono means one. And so that means that I have one term. Well, that could be a number like 11. It could be a variable like n, or it could be the product of numbers and letters. So we could say something like negative 6x squared. All three of those are examples of monomials. Monomial means one term. Now, the next term up here is polynomial. Now, we've seen that word poly. We said poly means many, and the key to this is it's the sum of monomials. So it's the sum of many nomials. Now, I'm going to be a little bit radical here. How about if I gave you 15x to the fourth minus 7x cubed plus x squared. Let's do minus 3x plus 32. All right, so that is a polynomial. I've just got a string of monomials with separated by plus signs and minus signs. And you can say, but Mrs. Burton, it says the sum of monomials. Well, remember, the definition for subtraction is to add the opposite. So it could have a plus sign in between them or a minus sign in between them. So polynomial, the sum of many nomials. All right? Now, third term, binomial. Well, we know that bi means two, so it's two terms. Now, we've seen this a lot already. It'd be something like x plus 4, or it could be 3x minus 15. And then the last term on the slide is trinomial. Tri means three, so it's three terms. It's going to look something like this: x squared plus 6x plus 8. All right, that's our quadratic equation. That's from chapter 5. And so, got to be able to know the different terms as we go through. Now, or wrong way, sorry. Now, in the monomial negative 6ab squared, we're going to see that negative 6, that number out in front, is called the numerical coefficient. Now, we've heard that term coefficient before. Monomials that are exactly the same, except for their coefficients, are similar or like terms. Now, we're going to see, now that we're in chapter 4, like terms means the exact same letter with the exact same exponents. And that's an important thing for us to keep in mind as we start down this journey of chapter 4. Now, what are some examples of like terms? Well, we know that's going to be something like 11x plus 4x. It could be 6x squared y minus 2x squared y. If you notice, my letters and my exponents are exactly the same. The only thing that's different are the coefficients out in front. Now, a real important thing to keep in mind, let's say I had 6n squared plus n. Are those like terms? That's right, they're not. They both have the exact same letter, but the exponents are different, okay? And since the exponents are different, then they are not considered like terms. And if they're not like terms, I can't put them together. And we'll see a little bit more of that as we go along. Now, we've got a new idea to tackle. This word degree. This is the first time we've seen that. And it says the degree of a variable in a monomial, remember what a monomial is, just one term, is the value of its exponent. So when they're asking us about degrees, we're looking at exponents. So let's say I had 6n cubed. Well, there's only one letter, and its exponent is 3, and so this would be the third degree. Okay? Now, it says the degree of a monomial, remember, one term, is the sum of the degrees of its variables. So let's say I had a coefficient. Let's go ahead and keep it 6. And let's say I had x cubed y squared z. Now, did you notice I've got more than one letter and I've got more than one exponent? So how I find the degree is to just add up all those exponents. Now, you got to realize that z has an understood 1 for its exponent. So if I add all these up, we got 3 plus 2 plus 1. So this is actually the 6th degree. So when they're talking or asking us questions about degrees, we're looking at exponents. That's what that means. Now, let's change it up. And this time, I want to know the degree of the polynomial, different word. The degree of the polynomial. The definition says it is the greatest of all the degrees of its terms after it has been simplified. So, let's say I gave you this. Let's say we had 15x squared y squared z. And then let's do minus 4x squared y plus 11. All right, now we have to look at each term and figure out its degree. So if I look at the first term here, well, there's my variable. So let's look at my exponents. We've got 2 plus 2 plus 1, which is 5. If I look at my second term's variables and exponents, its degree is 3. Good job. Remember that understood 1 there with a y. Ooh, what happens if all I have is a number? There's no variables, no exponents. Very good. That means this one's degree is 0. So the degree of a polynomial is the greatest of all the degrees of its terms. So when I look here, after I figured out each term's degree, the big one wins. All right? So 5 is the bigger degree, so this would be the 5th degree. Okay, we'll practice a little more with that. Now, we're going to see a polynomial is simplified when no two of its terms are like terms. So if there's no like terms, then we're done. Now, we're going to see in the book they're wanting us to add our polynomials, okay? Now, when they say add, I'm really just collecting like terms. Now, we're going to see there's 2 ways to get the job done. The first method in the book they show is the vertical method, which means we've got polynomials on top of each other. The second way they show is horizontal, which means it's all drawn out in one big string. Now, personally, I don't care which way you add them, okay, whether you're going to go with the vertical method or the horizontal method. I just need you to pick one and perfect it. So if I'm looking at number 1 and they want me to add those, and it just says add, and here's polynomial number 1, and here's polynomial number 2. Now when it's in the vertical method, if you notice my like terms are already in the same column. So I just have to add down. So if I look there, let me get rid of that. So when I look there then, okay, my n squareds are like terms. So 1n squared, remember our understood 1, plus 3n squared is 4n squared. And now I look at the n's. We've got negative 4n and 7n. Well, those are different signs, so I'm going to subtract and get 3n. So basically, I just took my like terms and I added them together. Now, can I combine these? Can I put these together? No, I can't. That's right. Since these are not like terms, they're different terms, I'm done. I'm finished. Now let's go over here and look at number 2. When we look at number 2, this is the horizontal method. Now, it's kind of long and drawn out. We've got to figure out who to combine with who. So if I look here and I have negative 3x squared, which one of those monomials listed after that is a like term? Well, if you notice, nobody else is just plain old x squared. So that one doesn't have a like term, so it's just going to come along for the ride. Who's going to combine with positive 7x squared? Do you see a like term? Yeah, that's right. Negative 3x squared. So 7 and negative 3 is positive 4x squared y. All right, who's going to combine with negative x cubed? Oh yeah, we've got 4x cubed, so we've got like terms. Now remember, there's an understood 1 in there. So what's negative 1 plus 4? Oh, that's positive 3x cubed. And then if you notice again, I've got xy squared. He doesn't have a like term to combine with, so he just comes along for the ride. Now if you look, is there any two terms I can combine? No. And that's why this is called simplified. It's simplified when no two of its terms are like terms. So we're done. So you've got to decide, do I like the vertical method or do I like the horizontal method? Now, we've been talking about addition, but what happens if I have subtraction? Remember, subtraction, we learned back in chapter 2, means to add the opposite. Okay, add the opposite. So that means that everybody who comes after the minus sign has to change their signs. Now, personally, I like the vertical method. So what I like to do is this is my polynomial that comes after. So what's the opposite of negative y squared? Well, that's positive y squared. What's the opposite of negative 7y? Well, that's positive 7y. What's the opposite of positive 4? Well, that is negative 4. And now we just have to add our like terms. What's y squared plus y squared? Very good. 2y squared. We've got negative 3 and positive 7, which gives me positive 4y. We've got negative 5 and negative 4, which is negative 9. So you've got to remember what subtraction means. Okay, subtraction means add the opposite. So anybody, the polynomial that comes after the minus sign, you have to change everybody's sign. Now, let's go ahead and look at the last equation here. And it's plus, so we don't have to worry about anything. Who's going to combine with 2x squared y? Oh, yeah, we've got 2x squared y over here. So that's going to give me 4x squared y. Who's going to combine with negative 3xy squared? We've got negative xy squared. Did you notice they're the same signs? Both of them are negative. So that's going to give me negative 4xy squared. And then negative y cubed is alone. Doesn't have a like term, so he comes along for the ride. So, point. Be very careful when you're looking at your signs. Decide, do you want to do the vertical method where you list them like terms on top of each other, or do you want to do the horizontal method where you kind of got to go back and forth and find like terms? So we'll see how you do, and we'll figure out which way you like best tomorrow. Now, last problem we need to look at. Ooh. This time it says solve. What does solve mean? Well, number one, did you realize I got an equal sign this time? Okay, we've got an equal sign. So that means when I'm solving, I'm going to have to isolate the variable by inverse operation. So we've got to get n on one side, and we've got to get numbers on the other. We've got a lot of distributive property to take care of first, though. Remember, we're going to take the number on the outside and multiply by the number on the inside. So 3 times n is 3n, and then 3 times negative 2 is negative 6. Ooh, did you realize I got negative 2 out here? Red flag's waving. So now we're going to say negative 2 times 3, which is negative 6, and negative 2 times negative n, which is positive 2n. Again, you've got to really watch out for your signs. Equals, and we got to do distributive property one more time. 4 times 2n is 8n, and 4 times negative 3 is negative 12. Now, we did something like that back in chapter 3. What do you think we need to do next? Ah, that's right. We got to combine like terms. Who's going to combine with 3n? Well, 2n is. What's 3n plus 2n? 6n. What's negative 6 and negative 6? Well, that's what? Negative 12 equals 8n minus 12. Ooh, now we're back to chapter 3. This is what we learned to do back in section 3.5. Now remember, if you need to, you might want to draw your line to get your x's on one side, numbers on the other. Ooh, you know what I just did? I just found a mistake. I said 3 plus 2, but I wrote 6, okay? So this should be, okay, I multiplied them instead of adding them. So this actually needs to be 5n, all right? Now, I want to keep my n's positive, so I'm going to subtract 5n over here. The bigger n is on the right side, so I'm going to go that way. So now I've got negative 12. Now, 8n and negative 5n, different signs, so that's going to be 3n minus 12. Oh, that's right. My floater this time is 12, so we're going to add 12 to both sides. Oh, what happens to my 12s over here? Remember, those are additive inverses. They're going to cancel each other out, and we're going to get 0 equals 3n. Now, n still isn't alone, so I need to divide both sides by 3. What's 0 divided by 3? That's right. So we're going to get n equals 0. Great job.